Hey, and welcome back to another video. And in this video, we'll actually take a look at how we can, unit test our networking code that we rewrote using Swift Concurrency. So the class we're actually going to unit test is our network manager that we use within our view models here. So what we want to do is actually just go into our network manager and take a look at what it is that we want to test. So let's click into here. And within our networking manager, there's a few things we want to check. So we actually want to check to see if the request is built properly. That's the first thing. We also want to test to see if our responses get handled for whether something goes wrong or if something is successful. Now, if you want to learn more about APIs, then check out my video, What is a REST API within the SwiftUI take-home test course. But looking at our networking manager, you'll realize that we're using URLSession here to make our network requests. Now, this is something that we actually, don't write and control, since it's something that we get from the Swift framework because, we didn't build URLSession here. Now, what we're actually going to do to tackle this is we're going to need to use Dependency Injection, which you can actually understand and check out from my previous video that breaks this down, as well as the difference between mocks and stubs. So first of all, let's actually look at tackling how our request for each one of our endpoints is built properly. And we're going to need to create a networking folder for holding all of our networking manager tests. So let's go into our project here. And then in our take-home test, we're going to create a new group called networking. And then because we want to test our endpoints, we're actually going to create a new folder in here called endpoint. And then we're simply going to create a new unit test case class called networking endpoint tests. And then make sure that we save it. Well, not save it, but make sure that we create within our testing target. Cool. So you should get this whole template generated. Now I'm just going to remove this. Cool. So now the first thing we're going to do as usual is we're actually going to define the test cases that we want to write our tests against. So I'm just going to type this out and then we'll break it down. Sweet. So what we're doing is we're essentially going to write tests to make sure that each endpoint that we have within our endpoint enum is valid. So you can see here, and we've made sure that they all fail. So if we run this, they should all fail. Cool. So the first endpoint that we actually want to validate and check if the URL is being built properly and see if the whole URL is correct is our people endpoint. Before we actually crack on with our first, test here where we validate our people endpoint, one thing to note is that within these tests, we're not actually going to use the setup and the teardown function. Now, the reason why is because we're actually testing each individual case within our endpoint enum. So let's first of all, in our function here, we'll just define a constant to hold the endpoint. So let's just import our target so we can access this endpoint. Cool. And then within our function, we'll create a constant to hold the endpoint. So we're just going to say people endpoint. And then we're going to say endpoint dot people, and then the page is going to be 1. Cool. So now within here, there's a few things we want to test within this endpoint here. And we want to make sure that the base URL, the path, and method type is, all valid. So we just click into endpoint. Essentially, we just want to make sure that all the values for our computer properties are correct within this file here. And the final resulting URL is also correct as well. So let's first of all start off by just testing that the host is correct. So let's do that now. So in order to do that, we're just going to say XCT assert equal, and then we're going to say endpoint or people endpoint, or just to save typing, let's just rename this to endpoint so we have to type out so much. So we're going to say endpoint dot host, and then the host we're expecting here is going to be request.in. And the message that we want here is that the host should be request.in. Cool. Now we also want to basically write a test as well for our path as well. So let's do that now. If you go into our endpoint file, you'll notice that the path that we defined for our people is this /API/users. So we want to make sure that it's equal to this. So I'm just going to copy this and then paste that in here. And then we're just going to say the path should be that. Cool. Now the next we want to check to see is that the method type is get. And then our message here should be the method type should be get. Cool. Now, before we carry on, you should notice that we actually have an error here. And the problem that we have here is that if you actually click into method type, you'll notice that our enum method type cannot automatically conform to the equatable protocol. Now, the reason why that is because our post case here actually has an associated value. So if this didn't have associated value, we'd actually automatically be able to compare our enum cases, but because it has a type, but because it actually has an associated value here, what we need to do is actually just mark this with equatable. And when you go back into your test, you should realize that the error actually goes away. Cool. So now we've done that, the final thing that we want to test, well, not the final thing, but the next thing we want to test here is the query item. So we want to make sure that if we pass in a page number of 1, our query items has that key value pair. So let's do that now. And then we're just going to say here that the query items should be page 1, like so. Cool. Sweet. So before we actually test the whole URL that's actually built out, let's actually just run this and see if it's okay. Cool, and you should see that it's actually working fine. Now, if you see this failed here, it's actually not failed. It's just that Xcode is being a bit doo-doo, and it's not actually picked up that, the test, wasn't running. Is the test from before that we initially did with the XCT fail has been cleared. But all you need to care about is a little tick here. So this is all fine. So the final thing we need to do is actually test our whole URL that's actually built out by our endpoint. So let's just do this one now. So we're just going to say XCT assert equal, and then we're going to say endpoint.url. Now the URL that I'm expecting it to basically spit back to us is the URL where it's the whole API with the page and also a delay as well. Cool. And then we're going to say that the generated URL doesn't match our endpoint. Cool. So let's actually just see what happens. So if we just run this test now, well, what we want to do is not actually just test the URL. We actually want to test, we don't want to test the URL object. We want to actually test out the string of the URL. So let's just run this and see what happens. And you'll see that our test actually fails. So if we actually look at why our test has failed, it's actually saying here that we said that we want to test to see that the string matches this delay page 1. But if you actually look at our message, we actually have it where we actually set within our endpoint file that the delay should be 5, but we're checking the delay should be 3. So let's actually just update this. So if we go into our endpoint file now, we'll change this, rather than it being 5, we'll actually just go all the way down to 2. And then within our networking endpoint test, we'll also change our delay here to 2 as well. So now let's see if this fixes our test. Cool. And you should see now that our test has succeeded. Sweet. So now that we've actually done this for our people endpoint, we essentially need to copy the exact same for all of our other endpoints as well. Now, some of our endpoints do have some differences, so we'll just get into the habit of actually just typing this out from scratch. So let's remove our XCT fail, and then we'll create our detail endpoint here. I'm also pass it an ID of 1, like so. And then we'll assert again the host and the path. And then this time, I'm just going to copy this. But our path here is actually going to be a bit different, because if we go into our endpoint for our detail, you'll notice that the path actually has an ID on the end of the path. So if we go in here, we actually want to change this to be an ID of 1. So we don't have to repeat this. We're just going to create a new property here called user ID. This could be equal to 1. And we're going to pass in our user ID in here and our user ID within here. So the reason why I'm doing that is because I don't want to get into a situation where I accidentally forget to update one and not the other. So it's just always within this constant. And then we're going to update this to now also show that user ID. So let's do that now. Awesome. Sweet. So carrying on, again, our endpoint type for this detail request is actually a get. So I'm just going to copy this and then just paste it here. Cool. And then we actually don't have any query items. So we actually want to assert here that our query items are actually nil, because we don't actually set any query items. So we're going to use a new assert here, and it's called XCTassert nil. And then we're just going to check our endpoint.query items, and then we're going to type in our message here that the query items should be nil. Cool. And then the next thing we're going to do as well is we're going to assert that our URL is equal to what we expect. So I'm just going to copy this. Okay, cool. So let's actually just update this URL, because there's some things that we do and don't need. So the first thing that we don't actually need is this page here. So we can delete this ampersand and this key value page, because we don't have a page within our detail. And we also need to put the ID that we need at the end of our path here. So we're just going to use a user ID constant. So you can see the benefits of us using this constant, because we're essentially able to basically just easily pass in to user ID. So let's run this and see what happens. Now you should realize that the test actually fails. So if we open this up, the issue that we have here is that our URL here doesn't actually have our delay query item on the end of it. So when we test out this with a debug build, we actually purposely add a delay because the API is quite quick, so we can see our loading spinner. So let's actually go into our URL computer property, and we're going to need to debug what's going on here. So if we just put a breakpoint here, and then this time we're just going to run our tests. So actually just run this test now. And in our endpoint file, if you open up self, you'll be able to see what case is being tested. So for some reason, I'm not too sure why, the people test is being run, but we don't want that. So let's just hit next. Cool. And this is the one that we want. So this is the detailed test here. So as you can see here, our query items is actually going to be, I think it's going to be nil. So if we actually step over this, you'll see that our query items is actually still nil. So because our query items here for our request query items is nil, we're actually not able to actually add anything within it. So if I go on to the next line here, you'll see that it's still nil. So in order to actually fix this, what we're going to need to do is actually create an instance of a query items, which is an array of query items that we can append to. So if this is actually ever nil, we can still add values within it. So this is how we've actually been able to find out what the issue is by debugging and looking at what is inside of our properties. So let's actually just stop this from running. And then the first thing we're going to do here is create an instance of an array of URL query items. So the next thing we need to do after doing this is actually, rather than us using a compact map, we actually want to use a for each, where we essentially loop through all of the items and add them to our request query items. So within here, we're just going to say request query items dot append, and then we're just going to pass in our URL query item like so. Cool. So we use the items, key, and name for what we want to append, and now we can remove this. Sweet. So now within our if debug, because we have this array, we can just append a new item, and because this is not, optional no more, we can just simply remove the question mark. Sweet. So now let's go back into our network endpoint test and see what happens. So now if we actually just run this test, cool, you'll now see that it actually passes. Awesome. So let's go into our test here, and what we want to do now is actually write a test to basically validate that our create request is actually built properly. So let's do that now. So again, we're just going to create our endpoint. Now for our submission data, we're actually going to set this to nil because we don't actually want to test any data that's being sent. We just want to test that the URL is just basically built properly. And then we're going to do the same thing again where we test the host. And then we're also going to test the path. Now the path for the create endpoint, if we just go into our file, you'll see here that it's actually the same. So we can essentially just kind of like just copy this from our path here. Cool. Now our method type is a bit different. So rather than it being a get, it's actually a post request this time. So let's just copy this, and then this time we'll change this to post, and our data, we'll set it to nil. And we'll also change the message here to say it should be post. Cool. And then for our query items, if we look at our endpoint, you'll see that for our create, it also should be nil as well. So we're going to copy our assert nil here. Cool. And then we want to assert the URL absolute string. So because it's similar to this, I'm just going to copy this and then paste it. But what we just need to do is just tweak it a bit because we don't have pages within our create endpoint here. So let's just remove this key value, and then we'll just make sure we have our delay like so. Cool. So let's actually just run this test and see what happens. Cool. And you can see that our test actually passes. So our URLs for our endpoint and the properties and parameters, whatnot, are all being set properly. Sweet. So now moving on, what we want to do is actually test our networking manager and make sure that we're sending back the correct response when we make a request. But essentially what we're going to have to do is actually create a mock of URLSession for the different scenarios, since like I mentioned before, we didn't write URLSession, so we can't control how it works. But what we can do is we can use a protocol to help us control whether there's a success or a failure. So similar to like what I mentioned in our unit testing video previously, we don't want to actually test this against a real API, because if the service goes down, then so do all of our tests. So let's actually create a new folder within our networking folder, and we'll call it mocks. So this folder is going to hold all the mocks that we use to simulate, basically a success or failure for our flows. So within this mocks, we're going to create a new Swift file, and we're going to call this mock URLSessionProtocol, because this is the protocol that we're going to create to allow us to control how our URL session works. Cool. So what we need to do for this is actually use the URL protocol. So let's just type this out. So we're going to say class and then mock URL session protocol. and then we're going to need to use the URL protocol here. So this allows us to actually control how our data is going to be loaded when we want to use, some kind of request with our networking manager URL session. So we're just going to use this. Cool. So with our URL protocol, there's actually a few functions that we can actually override to control how our request is handled when we execute it, within this fake mock. So the first one that we can use is we can use this called Init. And what this allows us to do is it allows us to actually control whether it can handle a given request. Now in our case, we actually want it to always return true because we always want it to return some kind of value for when we try to execute this fake request. Now the next one that we want to do is Canonical Request. And what this does is it actually returns a fake version of the request. So we're just going to return our request that we pass in here, like so. Cool. And then moving on here, we're going to use the start loading function. Cool. So this start loading function is where we actually control the mock response that we get back from this fake URL session that we're going to build. Sweet. So now that we actually have that, we need to actually write some kind of like closure to actually help us handle simulating our request. And we're actually going to tackle this step by step. So with our closure, we're essentially going to pass it some kind of like data and fake HTTP response that we want our URL session to return to us. And if you want to learn more about the purpose of closures, you should check out the video within my SwiftUI sessions course. So let's actually just type this out. So it's actually going to be a static closure. So we're going to say static var, and we're going to call it loading handler. And this loading handler with this closure essentially is going to, be void. So it's going to be void here, but we're going to be able to actually return some kind of values. Now the values that I want to return is a HTTP URL response and some data if I want it. Cool. So the reason why we're returning data and a response within this closure, and we're also going to mark it as optional. Cool. Oh, cool. Sweet. So the reason why I'm actually, returning within the closure that where we're going to use this, a HTTP URL response and a data, is so I can actually set within the network request that we simulate the status code and any data that we get back from this fake, URL session. Cool. So we actually need to use this handler within our actual start loading function. So let's just type this one out together. So the first thing we need to do is when in our handler, I want to make sure that whenever you call it, that it's actually been set and it's not, nil. Now, because I'm using XCTest here, I need to make sure that I actually import the XCTest. So what's going to happen here is that whenever we use this handler, if it's ever nil, we're actually going to just basically bomb out and just call a failure because we always want it to return something. So let's actually just use Control I to clean this up. Great, cool. Now the next thing we want to do is we actually want to get our response and our data from our handler so we can actually pass this into our URL session request. So let's actually get a tuple representation of this. So we're going to say response and then data and then handler. So now this is going to get us back loading handler. Handler. So this is actually now going to get us back the values that we actually set within our closure from our constant here. So now we have access to the response and the data. So what we want to do now is actually send back the response and any data that's been, set. So we're going to say here client, which is the URL session client, and then URL protocol did receive. And I'm going to say self, and then we're going to say did receive response, which is the response we're trying to simulate. And then one more thing I want to do is set the cache storage policy to be not allowed. So we're going to basically make sure that we never cache any of this API data onto the device during our test, because we want it to always be within a fresh state whenever we're actually running our tests. Cool. So the next thing we want to do is we actually need to set our data. So we're going to say here if let data, because remember we marked our data as optional, so it might not have a value. So we're going to call our client, and then we're going to say URL protocol did load. So this is going to allow us to actually send data back within our URL session, and we're just going to send back the data that we passed through. Cool. Now the final thing we need to do is actually tell our client that we've actually finished loading. So we're going to say client.URL protocol did finish loading self. So this will actually stop our execution. So this is essentially us simulating an API where we actually make a request and you get some data back. Cool. So what we need to do now is actually create a test file to actually simulate us actually testing out a successful response. So to do this, within our Networking Manager folder, we're actually going to create a new folder within here called Networking Manager. And then we're going to create a new test class called Networking Manager Tests. And then that's going to be part of our test target. Cool, sweet. So let's actually just delete all of this. And then within this class here, what we're now going to do is we're just going to write out the body of our unit test for what we're going to test. So what we want to test here is whether a successful response, if we get back a successful response from the API, does our networking manager handle it properly? So let's do this now. Cool. And now we've got the name of our test sorted. Cool. So similar to what we did in our previous video for our validator, where we actually create a setup for each one of our individual tests, we want to do a similar thing here where we essentially set up our fake URL session protocol for each one of our tests before each one of them actually run. So what we're going to do is actually create two properties. I'm going to go call one session, which is going to be what holds our URL session. And we're going to create another one called URL, which is going to be the URL that we're going to simulate within this test. So the next thing we need to do is actually type out and create our setup and our teardown functions. So let's do that now. So we're just going to say setup and teardown. Cool. So within our setup function, we just want to set up the URL that we're going to simulate. And in our case, this is the request in API. So in here, we're going to say URL is equal to the URL. And then the string here is going to be HTTPS and then /request.in/users. Cool. And then after here, this is where we're actually going to create our fake URL session, essentially. So the first thing we want to do is actually create a configuration with a URL session config of I can never say this word. Ephemeral, I think that's how you say it. Configuration. So the reason why we're using this URL session configuration here is because between each and every single one of our tests, we want to make sure that the state of them is clean. So we don't want to have any data that's been cached on the users, we don't want to have any data that's been cached on the device between tests. So after doing this, the next thing we want to do is actually set our configurations protocol classes. So it's this bit that actually hooks up the mock that we just created before to our URL session that we'll execute in a second. So within here, we're going to say configuration and then protocol classes. And then the protocol class that we're going to pass in here is going to be our mock URL session protocol dot self. Cool, sweet. And then the next thing we need to do after this is actually set our session, so our URL session, to be the configuration of what we've just set up here. So we're going to say session is equal to URL session, and then the configuration here is going to be this configuration. Cool. So now between each one of our tests, we actually have a mock URL session protocol that we can easily use to actually simulate what data we specifically want to send back and the status code. So within our teardown, we want to actually make sure that we set both our session and our URL back to nil. Cool. So we're almost there. Now, the next thing we're actually going to need to do is actually slightly refactor our networking manager to accept this version of our URL session. So if we go into our networking manager, you'll notice that it actually has a URL session directly within the actual function. What we want to do instead is we actually want to have it where you can actually inject and pass through your own URL session. So let's actually just change this now. So within here, we're just going to update our function signature this time to accept a URL session. So we're going to say session and then URL session, and then its type by default is going to be .shared, like so. Cool. So now we have this in here, we're actually able to use dependency injection to pass in our own version of a URL session, which is the one we created before within our networking manager test. So this is what we're going to pass in. Now we're going to need to update our function to actually use our session. So we don't want it to be this. We want this instead to be session. Cool. And we also need to do the same for our request function below as well. So we're going to add in here session URL session is equal to .shared. Cool. And then similar thing again, we just want to take this out and replace it with session, like so. Okay, cool, sweet. So if we just build this, we should see that everything builds fine, which is perfect. So now we're ready to actually use this, and actually test it within our networking manager tests. Cool. So let's actually look at our first test. So within our first test, we actually want to simulate a successful response. Now, because we're actually not connecting to a real API, we need to actually find a way to basically essentially pass through some kind of like dummy data and a 200 status code. So in order to do that, we're actually going to grab our JSON file and then pass this in to our mock URL session to simulate the data that you would send through within a request. Now, obviously, for us to do that, we also need to import our target like we've been doing before. So we're going to say testable import iOS take-home test project. And within our unit test function here, I'm just going to write some code that essentially gets that JSON file so that we can, pass it through. Cool. So what we've just done here is we're just using from our bundle resources, we're just getting the user static data JSON file. And if we can't get this file, then we're just going to call a failure and fail this test because we need this data for us to validate whether the test is correct. Cool. So after doing this, we're now at the stage where we actually want to create what we want our fake URL session to basically send back to us when we actually run this test. Now, in order to do that, this is where we use our protocol. This is where we use our handler within our protocol. So we're going to say mock URL session protocol dot loading handler, and then within here, we're now going to set what we want to send back. So we need to create a response. So this response is the HTTP URL response that we want to send back if it is, successful. In our case, it is. So the URL that we're going to send back is the URL that we create between our tests, like so. And then the status code we want to send back is 200 because we want it to, be an OK. HTTP version, we're just going to leave this nil because we don't really, test that. And we're also going to leave our header fields nil as well. Cool. So now we have our HTTP URL response set up. Cool. So within our closure now, we need to return back the data from here and our response. So let's do that now. And then one thing we also want to make sure is that we don't want the HTTP URL response to be optional. We just want it to be, we just got to force and wrap it because we've created an instance of it here. We know it can't be nil. Cool. Sweet. So now what we essentially need to do is we need to actually test and actually execute a request with our networking manager using the session that we created within our setup function. So underneath here, we're just going to type out underscore is equal to try, and then we're going to use the await keyword because we're using async await for it, and we're just going to say networkingmanager.shared dot. Now the one we want to use is where you actually decode it to a type, so we're going to use the first one here, and the session we're going to pass in is the session that we created. And then the endpoint that we're going to test here is the, we're just going to use the people endpoint just to, stub it with something. And then the type that we expect back is our user, response. So users response.self. Cool. Sweet. So you should see here that we actually get back an error. And the reason why we get back an error is because we're not within an asynchronous, context here. Now, how can you actually update your unit test to get support for Swift concurrency? Well, it's actually quite simple. And all we need to do is actually just mark our function as async. Cool. So now our function is, in line. So now we're able to actually test our, concurrent code with Swift concurrency. But one more thing as well is that our function here actually throws an error. Now we actually want our unit test to actually fail if an error is thrown. Now in order to actually handle that, what we can do as well is actually update our function signature to be throws as well. Cool. So because this is a successful, unit test to see if it handles a 200 and our data properly, what should happen here is we shouldn't actually get any errors thrown at all. This test should just pass, right? So to actually see if this works, let's actually see what happens. So we just run this test. You'll see that we actually get a crash. Now the reason why we get this crash is because you have to use this very important function within the mock URL session protocol. So we're going to a mock URL session protocol. We actually have to use a function called stop loading. So let's actually just add this in. Cool. And within the stop loading function, you don't really need to do anything. You can just leave it empty. But let's go back into our test. And then this time we're going to run it again. And you should see that it actually passes. So now we've actually tested that if we get back a 200 in our mock URL session, we actually don't get back any errors. Cool. So now the next thing that we actually want to do next is we essentially want to make sure that whenever we get back a response from the service, we're also handling any data that we get back, so it's all being decoded properly. So rather than us actually not storing the value, we're going to create a constant that holds the result. And then what we're going to do is actually compare the data that we get back from our, mock URL session protocol that we set here. We're going to compare this data to the actual static JSON file that we have within our project. So I'm just going to type this out and then we'll break it down. Okay, cool. So we have our static JSON mapper that we wrote test for before, and what we're essentially doing is an XCT assert equal with the response that we get back and our static JSON file. But you should see here that we actually get back an error telling us that we can't compare these two. So what we need to do to fix this is go into our user's response. We actually need to mark this as equatable. And we also need to mark our user as equatable as well. As well as our support. Cool. So now our model is equatable. So if we go back into our unit test function here and we actually build this, the error should go away. So you see it's built successfully and the error should go away. Cool. So let's actually see if we actually pass through some data and a status code of 200, does an error get thrown and do we get our data back successfully how we expect it to be decoded? Cool. So that all works exactly how we want it. Cool. So now the next thing that we want to test here is we want to test our alternative function where it doesn't actually return any kind of data, and we just want to make sure that it doesn't throw any errors. So let's actually type out the signature for this function. And you can see here that we're essentially testing to see a successful response is with a void is valid. So this is the alternative request function where we don't return anything. So all we want to do here is test to see if we set 200, does our request function not throw an error, because it shouldn't be throwing any errors. Cool. So we don't need to set up the bundle to actually get a file, but what we do need to do is set up a mock URL session protocol with a status code of 200, and we can just set our data to nil. So let's do that now. Cool. And then the next thing we want to do here is, because we're not actually comparing our result, we can just use the underscore and then call our networking manager, service. So we want to pass in our session that we set up between our tests, and then our endpoint here again, this is going to be people. We're just going to say page 1, and we don't need the type because we're not validating it against a type, so we don't need that. So this is all we need. Cool. So now let's actually see if this test works. Sweet. So you can see that this test works and none of the errors are thrown. So we actually don't get any failures. So this is all good. Cool. So we've actually done all the work that we need to and set it up the test for successful and our happy paths. But what we want to do is actually write some tests to see if we can handle the bad paths within our unit test. So the first test that we actually want to do for our bad request is make sure that if we pass through a status code of like maybe 400, for example, an error is thrown. So let's just type out the signature of this unit test function. So we're just testing here to see if the response code is in an invalid range. Now we've marked the function as async, but you'll realize that we've not marked the function as throws. Now the reason why that is because if an error is thrown, we don't want this test to actually fail. We actually want to capture the error within our unit test and do the comparison within there to make sure that it's correct, which is why we don't mark this with the throws keyword. So what we're going to need to do now is actually set our mock URL session this time to have a bad status code. So if you go into your network manager, you'll see that I actually defined a range here of what is classed as a valid range. So anything between 200 and 300. So if you have any status codes that's not within this range, it should actually throw this error here. So let's go back in here and we'll set up a mock URL session protocol, but this time we'll just set it to be 400. Now we don't need to return any data here because we're not doing any comparison with the data. We're just mainly checking to see if an error is thrown, if it's the correct one. Cool. So now what we're going to need to do is actually use a do catch to do that comparison. So we're going to say do, and then within here we don't need to capture the value, so we're going to say underscore, and then we're going to say try await, and then we're just going to say networking manager dot shared dot request. And then our session is going to be our session from before. The endpoint will be the people endpoint. And our type here is just going to be our user's response. So none of this is really important because we're not actually comparing, what we get back from the service. So the main thing here is the catch clause. So we're going to say catch. And then within this catch, this is where we now want to do our comparison. So within our catch statement here, the first we want to make sure is that it's actually a networking manager error. So let's add this in now. Cool. So as you can see here, we have our error as networking manager error. So if it doesn't actually get casted properly to this type, we're going to call a fail to say that we've got the wrong type of error. And now what we want to do is actually do a comparison with the invalid status code with this networking error. So let's do that now. So this is a little improvement here, just to explain this first. So we're actually just doing our comparison between our networking error and our invalid status code case. Now I've actually got 400 in two places here. So just to make this a bit better, I'm actually going to create a property here called invalid status code. And we're just going to set this to be 400. And we're going to set 400 here. well, not 400, we've got to set the constant there and the constant there, and now that's a bit better. But we also have another error here, and that's because our invalid status code, if we go into it, this networking error here actually has associated values. So because it has associated values, we're actually not able to just do, automatic conformance with equatable. So with this time, we have to use the equatable, protocol. But this one's going to be a bit different. So because we actually have the error here, this type error also doesn't conform to the equatable protocol. So we can't just mark it as equatable and then it will sort itself out. Instead, what we're going to need to do is actually, implement the actual protocol and do the comparison ourselves. So I'm just going to just type this out and then we'll go through this step by step. So underneath here, we're just going to say extension NetworkingManager .networking error equatable, and then we should get an error telling us that we need to add in the protocol, the actual implementation of this, which we'll do now. Cool. So within this function, what we're going to do is actually use a switch statement to basically do that comparison for us. So we're just going to say switch on the left hand side and the right hand side. And then now within this switch statement, we're basically comparing the left hand side and the right hand side. So what we want to do is we want to compare whether the left hand side and the right hand side case is the same. And if it is, then we're going to return true. So let's just do this for each one of our cases. So we're going to say case, and then we're going to do invalid URL, and then invalid URL. And if these two match, then we're going to say return true. So this means that they're the same. Let's do the same for our custom. So we're going to say case dot custom, case dot custom. Now, because custom has an associated value, we're actually going to need to access that to do the comparison. So we're going to say let, and then left hand side type. And then we're going to do the same thing, but this time we're going to say, rather than left hand side, we're going to say right hand side type. So right hand side type. And then within our comparison here, what we're going to do is we're going to compare whether the description, localized description, is the same for the right hand side and the left hand side. And if it is the same, then this will return true. Cool. So our next one is our invalid status code. So we're going to need to do a similar thing here. We're going to say invalid status code, and then we're going to say let left hand side type, and then invalid status code, and then we're going to say let right hand side type, like so. Cool. And then for this one here, we're going to do a comparison with the actual, status code that we pass through. So we're just going to say left hand side type is equal to right hand side type. Cool. And then our invalid data, we don't have any associated values, so we can just say invalid data dot invalid data, like so. And then finally, we're just going to return true. And then for our fail to decode, we're just going to be a bit lazy here, and then I'm going to copy this case, paste it, change this to fail to decode. And then one final thing we need to do is just say default, and for our default, if none of these match, we're just going to return false, because we only want it to return true if it meets these conditions that we've set here. And we need to say return false, like so. Cool. So we're essentially doing our own comparison for each one of our enum cases, as you can see here. So now you should see that our error actually goes away. So let's go back into our file, and then we're actually going to run our test and see what happens. And you should see that our test actually passes. So this is working how we'd expect it to work, which is pretty good. So the next thing we want to do now is we want to actually test the alternative, where if we actually send through the invalid status code of 400, but the function is the void version, it actually does the exact same thing. So just to make life a bit easier, what I'm just going to do is I'm actually just going to copy this test completely, and then I'm just going to rename this test a bit to say response code void, range is valid, cool. And then within this test, rather than having this type here, we're just going to remove it. And then now we can just simply see if it handles it properly as well. So let's run this test and see what happens. Cool, so that works as well. Sweet. So we've done our test now for our happy paths and also as well, our bad paths for the status code. But one more bad path that we need to handle is if we actually get sent back some invalid JSON, does our networking manager throw the correct type of error we expect, which is that it can't decode the JSON. So let's create a new test for actually handling this. Cool. So we've got our test here for handling a successful response with an invalid JSON being passed through to us. Cool. So what we need to do in this is we actually need to get our JSON file, but we're going to purposely mess up our request. So let's create our data. Let's get our JSON file. And now the next thing we need to do is that within our mock session protocol, we want to throw back a 200 and the data that we get back from our JSON. So let's do that now. And now what we need to do is we now need to try and call our networking manager, but this time we're actually going to purposely give it a wrong type to actually try to map and decode it to. So we want to make sure that if we give it the wrong type, it'll actually throw back an error telling us that it's failed to decode this object. So let's actually just type this one out now. So if we just say within here, we're going to say do, and then within our do, we're just going to say underscore is equal to try await, and then within our try await, we're going to say networking manager dot shared dot request, and then we'll go pass in our session, and then our endpoint here is going to be our people endpoint of 1, cool, and then for our type, we're just going to say users static or user detail response dot self. Cool. So now what we're trying to do is we're passing through our user static JSON, which is our array of users, through our network request. But what we actually have within our networking manager that we're trying to decode against is our user detail response, which is a completely different type of data. So this should fail. So let's actually handle this within our catch clause. So we say catch. Cool. So we want to make sure that the error that we get back within our catch clause here is a system error, because if you go into our refactor that we did before, we actually had it here where we tried to decode and we just propagate up the system error via this function. So in order to do that, we just need to do a simple comparison to say if our error is a networking error, our custom error type, then we're going to throw an XCT fail. So let's just say that here. So if our error is a networking error, then within here we're going to call XCT fail, and we're just going to say that the error should be a system decoding error. Cool. So now let's actually run this test and see what happens. Sweet. And our test passes, and the reason why it passes is because the error that we throw back is actually a JSON error. So actually just run this and just show you what the error looks like. You'll see that error, the type here is a decoding error, which is actually the system error. So this is all great. Cool. So now we actually have our test that we wanted for our networking manager, and we also handle all the possible cases that we need to handle for success and failure. Now in the next set of videos, we're actually going to start to look at how we can use integration tests to actually test our view models to make sure that the flow is correct. So if you actually enjoyed this video, I'd love to hear your feedback in the comment section below. Also as well, if you haven't already, I'd really appreciate it if you gave this video a thumbs up as well as subscribe to the channel and hit notification bell to get updates for whenever I release a new video. That's everything from me. I'll catch you on a bit. Deuces.